Hi there, everybody. Do you know if it's there or it got cancelled today? Call?
It's still here. I think we're just joining from another meeting. Sorry for the delay.
Hi, good afternoon.
Yeah, hi there, everybody.
Hey guys, Drew, if you're speaking, you're on mute.
Okay, can you hear me now?
Yep.
It's so frustrating. It's like I switch between teleconferencing apps. It picks a random mic. So anyway, I was saying good afternoon, and yeah, I think Yogesh is out. So but yeah, I think we want to try to go through the doc and see if we can get it close. I'm almost done with my action items. Sadly, not quite. But I made a lot of progress on the drawing. So I think we have something to go over today. And Seb, thanks for your comments. I went and did a lot uh, of the stuff you suggested.
Yeah, I saw that. Yeah, thanks. And yeah, I'm trying to go through the document because in the past it has always been kind of bits and pieces, kind of live, and I wanted to start from the start to get a better global view. And I'm not done, unfortunately. It takes a little bit of time, and I have a hard time finding the time. But hopefully, I'll go through all of it by sometime next week.
Yeah. So um, so we need to, yeah, I'll share the doc. Are there any opens before we jump into the review? Okay, I will, as soon as it lets me share. So, oh, we do have an update. So, we got vastly fewer OCP presentations than we wanted. Like not even close. So, and I think they said there were 55 uh, 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 submissions for something like 15 slots.
Yeah, 54 for 14 slots. Yeah.
14. So, um, so I'm pretty disappointed in what we got, but I understand. And I complained to people, and Yogesh's comment offline was, maybe we need to create our own track instead of being under hardware management. But that's kind of a drastic step. But I think over the next year we should explore uh, getting the right bandwidth at the global summit for all the work that's going on all the substreams.
By the way, that thought process, I initiated it a while ago, have shared my sentiment as well, as you mentioned about Yogesh. And I think we should start thinking, and may not be right away, but in the near future, to create a separate project. We can call it fault management, fault handling, RAS, whatever makes sense. Because especially with this whole AI infrastructure, there's a lot more interest now in the industry to focus on different aspects of RAS.
Yeah, I agree. So we'll work on that.
We're kind of handicapped with the management track because management is management, right? RAS is not the primary focus there. And that's what we are struggling right now.
Yeah, and it made sense for them to kind of sponsor us to get us started, but
Oh yeah,
we but there's enough differences between what they want to do and what we want to do that it may make sense for us to be our own.
And also when we started, right, our contributions, we didn't know, right? Now our contributions are so many, right, across open and CLA work streams. Yeah. And like, and there is a lot more interest, I think. But starting that work stream requires a lot of board approvals and yeah, that a lot more work to be done in that area.
yeah. Let's start the let the ball rolling now, right? So that maybe next year or year after next we'll get there.
Yeah. So when Yogesh gets back, we can start talking about that and.
Yeah. Put me in, Drew, from Meta, because we have a steering committee membership also, right?
Okay. Sounds good. So, and so with that, why don't we jump into the doc and see if we can get as much reviewed as possible? We're super close to being ready to release. And so, Seb, I hear you on consolidating things. We originally, there was once upon a time, we're all over the place, and we decided to go with server fleet operators because that was,
And I like that. And I like your definition at the end. So I think, in your definition of server fleet, like like, you said that it covers multiple stuff. I'm not sure, it says alternative, but I think maybe a more appropriate term, if it's the SFO can be an umbrella for a variety of operators or
it's a superset of hyperscalers. Yeah.
but I think what would be good is like my last point that I made recently, which is throughout the document we use different terms. So I think it would be great to consolidate. And I think what you guys came up with, like this SFO, is probably good.
Okay, I will. You know, we're kind of limited on what we want to do at this point because we're trying to
Yeah.
free. But
Mhm.
I'll take a look and see. Uh, see how. I'm willing to work on the change, but I think like I'm feeling a sense of urgency about just getting the in-band stuff released.
Mhm.
Sympathetic to Anil because I know Anil really wants the in-band released also. So let's try to balance forward progress with clarity there, and I'll work on it and see what I can do.
Yeah, and I think most of my comments are actually related to clarity, or I didn't see so far anything that was kind of like, hey, this is wrong, or yeah.
Okay.
So from that perspective, I think we're good.
Okay. Okay. And like what I can do is we'll keep if any comments we can't close for this release, uh I will try to carry forward so that we address them, you know. And so this one I think I addressed. I said
Yep.
possible performance impacts. I'm going to close that because you raised a good point. I agree with you. Okay. Um, where is the
On
CPU this drawing?
Yeah, on this drawing, I think it would help to define what the CPU covers, and I think actually the CPU in this drawing is, well, because the IMA is actually expected to be on the CPU, right?
Yeah, it runs in-band in the host OS. Yeah.
Yeah.
So, but you raised kind of a good point. The BMC is um, not in-band.
Hmm.
So Anil, maybe I'm looking at Anil because this is more his drawing, but I'm thinking what we could do is just put a block behind IMA and and say, host CPU or something.
Yeah, and I think that would work.
Is that okay with you, Anil? So, like this, and then I'll say CPU, and these are kind of bolded, so I'll bold it.
And by the way, it could be something that we clarify from the beginning in the document, that the IMA is expected to be kind of a software agent, not a standalone or whatever hardware agent.
Yeah, there's definitely what's the key that sends backwards? Okay. And I thought that was clear.
I didn't feel it was clear, and it goes to another comment that I have, which is sometimes I think in the document we are not clear about OMA versus BMC, and we kind of use them, it seems, interchangeably. And you see, the BMC is a hardware, basically, engine that is on the side, and the OMA is one of the tasks, I guess, that can be performed or should be performed by the BMC, right?
I think that's a very important distinction, and I'm glad to hear Seb make it. There's functionality, and then there's hardware in which that functionality runs. And it's really useful when you can identify those two things, because sometimes functionality runs on different hardware.
Mhm.
So, okay. Hold on one. I'm sorry. I'm trying to keep up. Okay. So I've modified this to say CPU. Daniel, are you okay with this change? I'm going to close it and leave it. And So let me get back to the comments you were just making. I'm so sorry. I'm just trying to.
No, yeah, don't worry.
You're going a little faster than I can type. So. Okay. And I'm going to mark it as resolved. And unless I hear any pushback, I don't really hear any pushback, so I'm going to go with it. Okay. Now, what was the comment you all were just making? I'm sorry. I think I missed some of your point.
My other comment was, and I mentioned that in some other comment later, but I think it's throughout the document. It seems often we use OMA or BMC interchangeably, or very often BMC instead of OMA. And one is a service, the other one is a piece of hardware, a hardware agent, right? So I think even here, right, when we say BMC, is on the BMC, we would have an OMA running. And what we talk about throughout the document is the OMA functionality that runs on the BMC, right? And
Yeah, I mean, we added OMA to complement IMA, but really,
which made sense. But
yeah, but I'm like not that sold on it. I mean, I will
Okay.
do it, but I prefer RAS API endpoint to be very specific. That we're just mapping. That there is nothing else needed. The RAS API endpoint and its protocols mapped to Redfish should be sufficient. So that's why I'm very ambivalent about the term OMA. But it's here, so I don't know. I need to
And
think.
then I think maybe it could be good to have just a short paragraph that explains that.
Okay. Yeah, that's going to be a little easier to make the change to the doc and and stay on track to submit it because we do need to get it submitted like ASAP. So what I'll do is let me think about this. I'm going to look for the first mention of
Hey,
the
Drew, sorry to interrupt. I had to step out. I think I was just watching you make some change in the diagram, right?
yeah.
I need to take a look at it. I think the way it is right now, it is not aligning with my intent of that diagram.
Well, we needed you to be here because we're trying to get this resolved.
No, I can do it real quick. I mean, because the IMA actually is software construct, right?
Right, but these are hardware construct.
Second?
So the BMC is a hardware construct, and it wasn't clear that the IMA ran on the CPU.
Oh, yeah.
Oh,
So Drew, maybe I'll just echo what Dean and Seb said. I think having the OMA inside the BMC to service, it makes a ton of sense. With the RAS API, the goal is to have a standard OMA that works across all the vendors, which is not possible today.
okay.
Yeah, so Seb's point that I reinforced, but you were busy focusing on the diagram, was that there are services, or what I call functionality, and then there's hardware that it runs on. And those, the services are really separate and different. They run on hardware, but they can also run on different hardware. So it's good to point out software constructs, functionality, services, and then show the hardware that you intend them to run on, or they could run on. So the IMA CPU is a good example, and OMA BMC, as Vilas just described, would be a nice symmetrical example.
I will try to make the document reflect that better. I want to get it released though. I mean, yeah, we need to balance perfection because perfection is the enemy of good enough, and so I'll try to clean it up
Yeah, that's fine. I guess just one other comment on the drawing. There's a line between the CPU and the BMC, and there's a bubble that says in band. Is that correct?
Drew, can you refresh it? I just edited it.
let me finish writing the comment for the previous thing.
I mean, it didn't come out very well, but at least I want to communicate my intent to change it.
Yeah,
I
the drawing was kind of blown away or something.
no, just refresh it. I think it should come out.
That
So,
looks.
so I wanted to separate out the hardware and software agents that, because IMA is a software construct, right? CPU is the hardware. And I think the font is changed.
IMA runs on the CPU though, so that wasn't. And you kind of put CPU at the bottom. It wasn't very clean.
No, sorry, I didn't finish it. I just want to show you that my intent. I can clean it up more, okay?
Well, okay.
Let me finish it. So the intent of this diagram is to provide a very high level context in difference between in-band versus out-of-band. If you go scroll down, the next diagram is where these details are there. So this was a very high level concept of in-band out-of-band. Yeah, here. Now here we can add OMA because we said BMC is OMA, but we can add OMA here. Otherwise, this provides clarity.
I think this is going to muddy the waters because we don't show where they're running. So
you don't have to not show that, right? Because this is a logical diagram. Right?
I think we're stepping off the deep end into a long debate of revisions. I think this is not on track to get this document released. So I'm
not suggesting to change anything here. I'm just saying that this is the diagram where whatever you were discussing earlier is clarified here.
And Drew, if we could just go back to figure 2, I have a suggestion and which might just solve this quickly. So there's a legend at the bottom which says what the IMA is. It says in-band management agent. In parentheses, we can just say software which runs on the CPU and add in OMA to that if we want to, something that runs on the BMC. That should do it, right?
Sure.
Yeah.
That'll work.
Keep it simple, right? I mean, don't make it too complex. With one little diagram, we can't show everything, right?
Okay, so we'll
right at the bottom of that, like.
Yeah, I'm just trying to move the table up a little, so we have room. So okay, and so you're saying
just in parentheses, we can say software or service or software that runs on CPU.
oh, that's nice. I'll fix the building in a second. Can you see the pictures I edited?
Yeah, we can see it
Yes.
as you.
Okay, cool. Okay, something like that. And then we need to, it would be good to put the what I would prefer is just have the OMA on the BMC. This isn't really a picture. This is a,
yeah, Drew, let me fix it. I think you wanted to show OMA within BMC, right? Or maybe similar like the software construct. I can do that.
Yeah, and I prefer showing it in it because the IMA in the CPU, running in the CPU, and the OMA is running in the BMC.
Yes.
Again, you're getting fixated in the actual implementation. We want to decouple where possible, right? Unless there is a very hard dependency.
No, there's no, the decoupling is that's an API thing. The point is the IMA runs on the host CPU. That's where it runs.
Not necessarily. Some part maybe in CPU, some part maybe outside CPU. I mean, it's an in-band agent, right? It could be split into multiple pieces, spread out. Yeah, it depends upon how we implement it. Simple
But it's
implementation, you're
okay.
right.
But the IMA is an agent. It's a software agent
Yeah.
that runs on some hardware. So in this instance, it's running on the CPU. I think I like it better like Drew had it, where the IMA is a box in the CPU box.
Yeah.
I think we should have the OMA box in the BMC box.
And Neil, I think I would distinguish error logging can be distributed among many things. You could have like an in-band process. You could have a microcontroller on the CPU that helps the IMA, but the IMA runs on the host CPU. It is an in-band management agent that exposes error logs from the host OS to the hyperscaler's infrastructure. And the OMA runs on the BMC. So even though it's helped by microcontrollers that run elsewhere also. So it really is that clean. And it needs to be that clean. We've never once talked about the IMA not running on the host CPU.
Yeah, so I want to keep this as generic as possible. What suppose system doesn't have CPU, is a non-CPU kind of system where controller is somewhere else, right?
Logging out of band.
Hmm?
You're logging, if you have no host and you have no host OS, you are logging out of band.
Anyway, that's
If
fine.
I had a storage appliance that was a network connection and a disk drive that does not run, a host OS, that is an out-of-band managed piece of infrastructure.
Okay, I'm not going to sit and argue. It's okay. I will fix that. Okay, I'll put the IMA into the CPU.
I have a quick question with respect to this. If you were having on the system, on the host, an ASIC that is dedicated for this task, and you're running your in-band software inside that ASIC, wouldn't that be generic enough? You're still saying it's a piece of
So
software
you're saying
that
like a network accelerator card or something?
what I'm trying to say is that it's a piece of software that you're running in band, so it's in the system, so you have visibility into system software and user software, but you could run it either on the CPU host itself, or you could have a dedicated ASIC or hardware CPU just exclusively for that work.
So I have to ask then, what's the definition of in-band?
Yeah.
We're resetting ourselves way to the beginning. What's the definition of in-band?
In-band agent is something that runs on the data center data plane. An out-of-band agent is something that runs on the data center control plane. It's that simple.
I mean,
So to Joshua's point, if ASIC is, in the data center data plane and it's running something, that's still an in-band agent. I strongly think, to Drew's points, we shouldn't try and rejigger the document at this point to fully flesh that out.
I agree.
We need to get this document out. I mean, we're like
Right.
this. We're trying to release it like, this week or next, right? So this is not the time to do something that fundamental. That's the sense of impatience you're getting from me, is that I'm very uncomfortable making big changes at this point. If it's small tweaks, it's fine. And if we want to make huge changes in the next version, that's fine. But we're really trying to get the document out in the next week or two.
But it's, I guess, Drew, Dean, did I answer your question? Like, I just want to make sure.
At a theoretical
yeah.
level, yes, but then
Yeah.
of course I would have more questions like what constitutes data plane. If it's a microcontroller,
we
so
gotta roll out what that.
Yeah, so I'm okay to stop talking because it's a very small point, but I think the notion, the figure is an example. The example is that this piece of software runs in this piece of hardware, makes it really clear. We're making it less clear, but the whole document is full of less clear things. So.
And so that's why, I really think put the IMA box in the CPU, put the OMA box in the BMC. It might be too big of a job to go replace BMC with OMA in exactly the spots where we need it to be replaced. But at least it's there, and then we can clean that up, later.
Yeah, there's no definitive diagram, but as an example, it's a lot clearer if you understand where software is expected to run.
Well, and so, like we could have, to Joshua's point, a smart NIC that runs part of the IMA, but it is still in the data plane. So let's leave it for now, and let's plan on coming back to that and making that clear in the next revision, because there are a host of other things we want to fix too, right? We've just got, artists never finishes their work. They mainly just give up, right? That's what all artists will tell you. And unfortunately, that's what we are here, is we just need to say this is good enough to get released.
So just give me an action item. I'll fix that today.
Fix the drawing.
Yeah, I think I brought back CPU the way you had before, right? A little bit of clean up. I'll fix the BMC part. I may have to redraw some part of it, but I'll keep the same intent, because I had to cut paste from somebody else's diagram, and I don't have edit right for that.
Yeah, you just have to redraw the diagram. That's what I have to redraw diagrams all the time. It's a pain. Okay.
Yeah, it's okay. It doesn't take much time.
Yeah.
So I'll fix it.
So my only remaining question on the diagram, that in-band, there's an arrow that says in-band that's pointing to a link between the CPU and the BMC. Like, what is that? Why is that an in-band thing? Like, just tell me out. What is that intending to?
I think I can speak to that. Let me see if I get it right, Anil. I think it's saying that in-band agents can ask the BMC for data that the BMC is monitoring.
Yeah, if you look at the table, Vilas, okay, there's a notion of on platform and off platform.
Yeah.
Okay. So if you look at the on platform, in band row, IMA to devices, comma BMC.
I don't understand how that.
No, what? Sorry,
what?
Say that again.
So IMA agent within the platform, when IMA agent has to interact with the BMC.
That's fine.
Right? It is still considered in band.
No. Oh, that's fine. But that's not what the drawing shows.
Yeah, that's what's showing.
No, it isn't. It's showing the CPU talking to the BMC.
See, that's one. Okay, okay, I have to fix it, because earlier it was only IMA, right? So it was easy for me. Now I have to fix it. Yeah. Good catch. I will fix it. Yeah.
Okay. Thanks.
Because I have to show now IMA, because it's kind of a little bit tricky, but that's okay.
Personally, I would remove that line. I get your point, but like, that's actually kind of the point you were making earlier, right? Like, the IMA is fine to be distributed, but if any part of it is running on the CPU, right, on the data plane, then it's a data plane agent and it's considered part of the IMA. So I personally think that line ends up being more confusing than illuminating, but it's a few. I think if you move the line to the IMA, then that's at least correct.
Right? Yeah, that's what I'll do. Right. CPU was not there before, right?
Yeah. Okay.
And there was a dotted line because the physical interface could be
up to IMA and then BMC, but it's a little. That was still a little. You probably need a solid line to the from IMA.
Yeah. No, okay. I'll make it solid now, because now we got CPUs. The idea was that all the devices, the highlight device was considered to be like a host. Sorry, a CPU. The whole thing is a whole system, right? With one bunch of devices, CPU is one of them. That's how I was picturing in my mind, and they are all interconnected. From a hardware point of view, that's all I wanted to show, because I want to really focus on in-band agent, BMC, and
so we'll let you fix it. Let's try to move on and get as many of these things resolved as possible, because we're halfway through and we haven't even gotten to the drawing that I updated, and that's going to take a while. So so if we can, let's just move on. We'll let you fix it, and then we'll come back when you're done.
Sure.
Okay, so Seb made the point we should define CCI in the glossary. And Seb, I took your exact definition and pasted that in the glossary. We'll come to the glossary later.
Yeah, same thing for the next one. I saw you.
I did the same thing. I made except you didn't suggest definition, so I made it up. So we'll review that later.
It looked good.
And I gave myself an action item on the next one. Okay. So you're asking, with IMA, it's desirable to run a standard. I think this is a little fuzzy because, we might define a standard, but you might have a hyperscaler that likes gRPCs or, some other protocol, and it's entirely fine if they make an IMA that maps the protocols for logging errors and sending CPADs to whatever they want. We may come up with a standard redfish one, and that's great, but we're not. The IMA can do whatever the IMA wants to. There's a lot more flexibility in the IMA than the OMA, in a sense, because the OMA is in the BMC, and we're only going to have so many. BMCs tend to be less customizable than software running on the host.
Yeah,
So,
just to clarify something more, the interface between IMA and the HS, the host management infrastructure, today is all proprietary. And there is an interest, but it's not a very strong desire right now. So therefore, we are just keeping it right now, but we're just calling out here that there's a need for it, and let's leave it there.
Yeah. So I'm going to resolve this. I agree with you, Neil. And if the interest becomes stronger, and we're going to have to define something for the BMC, a mapping of the RAS API protocol to the BMC. If that works well, there's no reason you couldn't adopt similar redfish interfaces.
Yeah, it's a slow migration. It's a natural gravitation toward that, right? But it's not very we are not blocked anywhere. From the BMC point of view, we are blocked.
You could copy it. You could make your own. You can do whatever. Exactly.
Yeah, because our tooling is so tied to the host that we land up in monkeying around with that anyway. So no matter what, all the interfaces, standards we put, it'll always help, right? And we'll work on it over time.
Yeah. Okay, Seb and I had a debate here. Seb, I'm sorry.
It's okay.
But the fact that you don't crash seems to me like the headline.
Yes.
And then all the other stuff is subservient to that.
Yeah,
So,
but it starts with platform shall return the control to OS context. And my only point there was we're talking about correctable errors. They may not all be exposed. So the filtering happens before, and whatever is exposed,
oh, I
is
see the
handled.
filtering. Well, the filtering may happen in hardware. Yeah.
Exactly. So we're talking about correctable errors here. So that's why,
I see. You're thinking in time order. I was thinking the top.
yes.
I'm
Okay.
sorry.
Yes.
I was thinking in terms of what's the headline of the definition. Now I understand you. Thank you for your patience.
Okay.
So you're saying that point one, we should call out platform shall return the control to us? Is that what you're saying?
Well, he's saying that the platform may filter the errors, but I don't know.
And it's programmable usually. So some correctable errors are going to be exposed, and then you're handling them.
So I think the platform may expose some of these to the OS.
And then I'm not like that. The best capability of the hardware possible need to be exposed or shall be exposed. Not some.
But again, the only way you're gonna get every we can reword this, Lenny. I'm fine with it, but the only way you're gonna get every error is a logic analyzer, because there's no hope of anyone logging errors at the rate at which the memory controller can generate.
Yeah, that's why I'm saying best for. Not best, but the hardware.
How about the platform exposes these to the OS context? Wow. The OS context, depending on overwrite rules and
Sorry. What's the intent of this list?
to define what a corrected error is. So
It's not doing it.
I think the intent here is because we are talking about requirements here. So when it comes to the correctable error, are there any specific requirements or anything that call out as a comment? Like storm handling is definitely one of them, right? Race
yeah,
conditions
maybe
is
it
one of
didn't
them.
time order, and maybe this is good enough.
Yeah, the first bullet item was really meant to be that maybe this was a little bit of context here because we are so used to and x86 with SMI. So I think that was the context here. Platform shall return the control to the voice context.
Well, even if you
And
correct that error in the memory controller, yeah, I guess. Well, how
so you can remove that, but first bullet, by the way, because now I'm thinking about first bullet is really kind of in the context of x86. Right?
Yeah, I think the error may not affect platform context.
Okay, so then I'm okay.
How about that? And that
Yeah,
kind of merges
that's
what you
fine.
were saying, and that merges the point.
Yes.
Like things keep running.
Yeah.
Okay, good.
I mean, may not, does not.
It depends on you could take a CMCI.
Well, may not, because there are cases where we have seen, right, the interrupts or whatever kind of interrupt, right, they get in the way of the scheduling of the
But
application.
even if you take an
And
interrupt at all, that did affect the platform context. You recovered, you don't crash, but you took a CMCI, so the context swapped into the CMCI handler, and then you logged the error and resumed. So, even in that case, you took the processor, even if you do fully in band, you stole the processor from the user so the OS could log the error, and then the OS goes back to the user. So that's a context swap at minimum, right?
Yeah. But then I don't understand. I mean, if we're saying the error sometimes does and sometimes doesn't affect the platform context, that's not a useful statement, right?
yeah, I think we should remove that sentence.
Okay.
Well, no, again, the reason I wanted to make that statement is because all correctable errors are not exposed.
Correct.
So they
no, hold
don't
on.
all affect the platform context because they are not exposed.
When you say not exposed, in what context?
Exposed to whatever agent you want.
Signal to software. How about that?
Signal, yes.
Yeah, basically a filtering kind of concept, right? The
Yes.
filtering typically, what at least from Hyperscope, from Meta point of view, right? We want to do the filtering in the software context, not in hardware. Hardware, we want
You have to do it in the hardware context because you can overwhelm software.
No, we will manage it. That's what the storm handling software concept.
It's usually programmable.
Every piece of your hardware does something. I know that. That's like a firm fact, right? But I think what you're trying to say here is that a corrected error does not affect the correctness of running applications, right? I think Dean had used that phrasing a while ago. Right?
That's the correct statement. We can make that. That's very, very non-controversial, right? The correct error correction or corrected errors shall not
of
application of running software even, right? Let's say it that way.
How about our software running on the host? How about that?
This application is good enough, but that's okay.
Yeah, and just does not, right? It's not may not, it does not.
Oh, it does
it
not.
does not.
Yeah. You're absolutely right.
Or shall not, actually. Shall not.
Yeah.
The error shall not, right?
Yeah.
If it's corrected, it shall not. Yeah. If it's then I agree. It's a shall here.
Yeah, it's a very non-controversial statement. That's the right statement.
Otherwise, it's not corrected. Okay.
Yeah, that's. I mean, hold on. Is that like, I think I see where you're getting at. I don't know if that actually answers your concern, but
Yeah, I think
is
that's
that
fine.
what you...
Yes, that's fine. I had a strong objection to the first point being attached to corrected. It's removed. This is good. Yeah, let's move on.
Okay.
I see. Okay, good.
Yeah.
Thanks. And your sampling is not mentioned in the doc, and that's a really deep can of worms. So I propose we get to that in a future revision.
Yeah, and that's perfectly fine.
Okay, memory kernel, they're uncorrectable. No. Oh, yeah. Well,
Yeah.
okay. But they are no. Here's why.
So
When
there are
the
two
hardware, hold
roles.
on, Neil, hold on. We've talked about this already. When the error is logged, the hardware says this is a poisoned error. The scope of the damage is limited. It's recoverable as far as I know. So we're talking about hardware severities here. And at the time that the hardware logged the errors, it was recoverable. But it turns out that the particular thing that was corrupted was needed. So we can't recover. So you can have a recoverable error in severity that is not recoverable. And that was the intent of this section.
Or if to make, I agree with your point, to make a slight semantic change, you can have a recoverable error which was not recovered.
Yeah, and here it is. That is already mentioned in the doc.
I'm getting confused. Which section you're talking about right now?
We're talking about, so his comment was in fatal, non-recoverable. And my point is, if you have a memory error that's uncorrected, that is a poison. And that is something where the kernel either recovers or panics, depending on the nature of the failure and the kernel's capabilities. So we've gone over this before.
Mhm.
Yeah. So I get now. So yeah, so this second row, right, is a non-fatal, non-recoverable, and if the page belongs to kernel, the hard page, right? I mean, sorry, the fixed page, sorry. Then it's a non-recoverable. So that belongs to there. Yes.
It's not poison. You know, like a poison.
No,
Like
it is poison.
No. When again, maybe you weren't here when we've gone over this table so many times. This is really not a productive use of our time today. But the non-recoverable when you log the error in the memory controller, you log it as a deferred error. That is a non-fatal recoverable error. You don't know at the time that you log the error in the memory controller whether that address belonged to the kernel or an application or whatever. So as far as the hardware is concerned, it's considered recoverable. And then the kernel decides, and as in bullet 6, whether or not it needs that data or not. And if it needed the data, it says, well, you may have called it a recoverable error, but I'm missing something I needed. So therefore I'm panicking.
I think, Drew, in my humble opinion, I think you're getting confused yourself. This in the first row, we are calling non-fatal recoverable. Okay, that means whenever there is a poison event, yeah, system recovers. Okay,
So
and then in the second row, we are classifying the cases where it's not recoverable, non-recoverable from a software concept point of view.
Well,
The hardware point of view is same
that's
behavior.
so the question then is this table for hardware? It says hardware error types right there. So
I'm telling you, we've
Drew's
debated this
explanation
ad
is
nauseum.
valid.
Yes, I'm a little frustrated. We've debated this ad nauseum, like literally for previous hours, and I really don't want to come back to this, Anil. Like we have
I
defined
don't want to
this.
come in also.
Clear.
I'm just trying to respond to the comment, right? I don't want to come again, right?
Okay.
We need to still respond to Shep's comment, right?
This is a statement about hardware severities. It is clearly possible to write a kernel that could recover from this type of error, even though modern general purpose kernels don't do that.
The mainframe kernels actually do.
Exactly. Yeah.
Exactly.
So
yes.
Right. And that's just an ROI statement in the kernel, right? So
yeah, the best of our knowledge. That's what we.
Yes.
Something like that is possible. Then let's change it. Then we need to need to fine tune our error classification, right?
The error classifications are fine the way they're written because they cover that case already.
Agreed.
Yeah.
Yeah.
Okay. So next, let's go let's see, HS management infrastructure on this picture. What is HS?
The hyperscaler, like that's part of like all those names that I guess we use. So
Did we define HS as an economy? I didn't see that, or was it there? I missed it.
that was my interpretation. So again, if it was not defined, then what is the definition of HS? And let's make that clear in the document. Here I was
Well-
mentioning the hyperscaler management infrastructure that we started to mention. So maybe if we consolidate the name, then Drew, this is going to be solved.
Okay, I think we should have just stuck with one name. So
It's a management infrastructure is what we call. I'm looking at glossary, right? Management infrastructure.
well, so
So this would be the SFO infrastructure management, right?
yeah, this is to make this match the doc. It should be server fleet operator infrastructure and server fleet operator policies.
Okay.
And this will be fleet. Oh, good, it fit. I was dreading it not fitting. Okay, so there. I think I can mark this as and I'll clean up. I'll clean up hyperscaler references. Okay. So let's see. I
That was good. Yeah, good
yeah,
clarification
I
on
added this
that.
statement, and this is to Anil's point that he's made it previously. But I was reading this section and I didn't see that they might be used simultaneously.
Yeah, it's useful.
So okay. Then okay.
Yeah, this is the cut and paste thing.
Okay. Never mind.
So here my point was the air monitoring agent, IMA, OMA, it's attached to the management infrastructure, but it's part of the platform, right? So I was a little bit
I
confused
think
by
it's
that.
between hardware in the system.
Mhm.
So it's between the hardware and these agents.
Okay.
Right? And then the agents, like what we're going to happen to do is map the same protocols that there'll be some mapping. Like you have a RAS API agent that can talk to the hardware no matter what it is, whether that's in the OMA or IMA, and then you'll map those protocol that API, the API or the commands in that protocol to whatever management protocol you use within your fleet.
Okay. So then maybe just clarify that in that sentence, because then I think the way it's written is fine. But yeah, it's the hardware platform.
How about we say
In-
hardware, comma,
Mhm.
the platform, and the management infrastructure interfaces, maybe.
So now I'm a
Yes.
little confused. You're specifying how the hardware talks to the agents?
Yes. So if you remember, we have these RAS API agents, and these are in the hardware. So when new hardware comes, these agents can speak to, for instance, the BMC. So yes, there's an interface to the, like if you think of this as the OMA on the BMC, and you think of this as the IMA, these agents provide interfaces, and we have a standard way to map those to this agent or to this agent. And then we have a CSP particular or server fleet operator particular way of mapping the RAS API to whatever protocol it uses. And it'll be redfish in many cases.
So you just said the RAS API agent is hardware?
No, no,
No,
yeah,
it,
but
it,
no,
it
no, no.
travels with the
You
hardware.
guys are you're talking about there. So Dean, right? They're standardizing how components talk to the platform. That's not necessarily the component in hardware.
I didn't
right?
think so. I think the
Yeah.
bottom half of the RAS API functional block understands how to talk to the hardware. That's not
Correct.
standardized.
Correct. That's what I'm
That could
saying.
be any old way.
It can be anything. You could
That's
have.
not what I just heard him say. I mean,
No,
if he
that is
agrees
what I
now,
was-
that's good.
No.
That's what I was saying.
It's components talking to the platform is the idea to standardize, not how components talk, how they manage their own component. Right?
Yeah, inside the hardware, you do whatever you want, but the out to the hardware to the management agent is standardized.
So there are two parts of standardization we are discussing. One is from component to the agents, and then from agent to the infrastructure.
No, you have to be careful because all the boxes say agents, right? It's from one vendor's product to another vendor's product, right?
Well, but
that's
an EMS management agent, IMA or OMA, right?
Sure, yeah. But but it said RAS API.
Yeah, from OMA to the infrastructure, right? So with OMA,
how all the components in the system talk to the OMA and the IMA. That is what's being standard. That is the goal of standardization.
And those components essentially are surfaced at the RAS API, right?
Yeah.
Yes.
What's below the RAS API is not being dictated.
No.
That is correct.
Yeah, correct. That's right.
Okay. All right. So RAS API is not hardware.
No, yeah, that's right. That is correct.
Okay. So I think I agree. I'm still going to be careful how you say things, but I think I agree.
It is an abstraction to the hardware.
It's an abstraction. It could be hardware. I don't think anyone would implement
it could be
right?
I would, If you wanted to implement a giant hardware state machine that implemented the RAS API, you could do it, but you'd be pretty dumb to do it because if it changed, you have to roll your hardware.
So let's go back to the sentence here and see if we agree on it.
I would actually just say between, components and the management infrastructure.
How about, can I say hardware components and management?
Then I come back to the same question. Why are you telling us how the hardware should talk?
Well, because you could have, because if you don't say hardware components, when you say components, it could be any random component in the system.
Are you telling me my memory controller has to follow this?
Through RAS API.
So the memory controller doesn't, the RAS API does.
Through RAS API. Memory controller does talk to infrastructure through RAS API, yes.
It's not standardized.
Yeah, that's internal. That's not standardized. We are not talking about that through RAS API. Or some sort of
well, you see what I'm saying? Components is too a little. There needs to. I don't care if it's hardware, but there's some adjective because component could mean.
How about platform agents?
Platform components may be good then.
Platform components, yeah. I was thinking platform agents, but I think the same. I'm thinking it the same way as Seb just said.
Yeah, that's fine. They just need another adjective there.
Okay. Sorry, but I just if you start telling me how to build the hardware, we have a problem.
So once again, Drew, I want to make sure. So between OMA and the infrastructure, are we not covering that like redfish kind of? How do we pull out the information?
For out of band, and you can use the same thing in the IMA if you want. But if someone wants to use a gRPC for the IMA, they can do that too. We're not specifying. We're going to work on it, but we're not mandating. Like the way I see it is the management agent to our infrastructure as hyperscalers is our problem. But we're going to map it to some redfish interfaces that map really closely to the RAS API for out of band for our purposes because that's really clean. And if someone wants to do that for the IMA, that's fine. Or if they want to use gRPCs or they want to use, COM calls or whatever they can. At the end of the day, they're going to need to map it to some form of error logging and actions. But they can do it however they want with IMA or OMA.
Okay, makes sense. I think that the diagram maybe we need to kind of again revisit then. Figure number 5. I think at high level makes sense, but there may be some nuances.
This one, or sorry, which diagram?
No, figure 5, which is further down. Because what we just discussing, right, that we kind of try to abstract it out here.
I think this is still consistent. You have, like we're gonna, for the out of band, we're gonna have a mapping to the RAS API. That our collector uses, and then once we get it into the collector, we'll have our own pub sub protocol for piping it through our infrastructure. So this looks perfect to me.
Yeah, so I think REST API collector, I don't remember seeing that, but that's an extra box here. There's a REST API in the green box and the REST API collector, and there's a redfish in between. So I'm assuming redfish is one of the standard we're defining here, right? No?
Yeah, we'll work on that for certain for the standard collector for the VMC. Yes, but you can use whatever you want for for IMA, and you can leverage what we did. I mean,
CSP protocol is fine. REST API to CSP such as CSP protocol is fine because we are not standardizing that. I think we are standardizing here this REST API box in between green boxes, right? To talk to the agents, embed agent. I think the out-of-band agent on the right-hand side is sort of a bit.
Yeah, I mean, so like if you look at the IMA, you could have an IMA requirement that said, I'm going to have a IMA collector, or the IMA could just push it up into the infrastructure, but nothing in CSP protocol prevents that. It's your choice.
Yeah.
So that's why.
Yeah. By the way, collector in our case, right, is part of IMA. That's what IMA one of the objective is to consolidate, do rate limiting and all that kind of stuff.
And that's fine. But again, you can do whatever you want with the IMA. It's like the abstraction layer is below the IMA. What goes above the IMA is your choice.
I was talking about the right hand side because I see redfish.
Yeah, we're going to define that for a standard collector because the VMC is less malleable than an IMA. So we want to map the RAS API protocol, and that's the way we're going to implement it. But if people want to put a different, people are vehemently opposed to redfish and want to do a different form of collector or have an IMA that pushes things up, they can do it, and they just map to the RAS API.
Sorry, my question is this part of the scope of this requirement to define this redfish interface here or not?
It is for the RAS API, so yeah.
Yeah, because what we just discussed, we were talking about the interface that we are defining here is between the hardware or platform components to the agents. This means up to the agent, out-of-band agent.
Yeah, I mean, that doesn't have to be redfish, is Anil's point.
And yeah, it does, and I agree with that. But my point is that we're going to do work to have a redfish, redfish interface that people can use if they want.
Yeah,
everywhere else, it different ways.
Yeah, that's okay. I mean, as long as.
It's fine. I mean, the rest of this drawing does not specify a specific implementation choice, right? I mean, I think it's making a reasonable point.
So maybe I should remove the redfish. I should remove the redfish then, right? Because we don't want to be prescriptive or something which.
Yeah, I don't care. I mean, I think it's a minor point, but you're making a correct point. Oh.
So what I was hoping we would go over today, I was hoping we were 2 weeks away, and I feel like we need to be really careful because we rehashed things that we've hashed out before. So let's try to be a little more focused. But I went through this out of band and in band example and updated it and moved all the dots around. So I've made a first pass at it. I was hoping to review it because I think that's going to take some discussion. So now I think we're getting further from the goal line, not closer. So we need to focus our comments a little bit and try to get there. But if you all could read the section with these diagrams between now and next week. That would be super helpful.
Okay, I gotta drop, but thank you.
Yeah, I've got to drop. I got to drop too. So we'll get there. But let's try to get this released. Like we're running out of time to get it to the platform, the hardware fault management, not the hardware fault management, the hardware management steering committee in time to get it released for the global summit. And we'd really like to get that done. And so if there's something we can defer to the next version of the spec, let's try to do it. Perfection is the enemy of good enough. Now, if it's egregiously bad, let's fix it. Let's get back to it. But otherwise, defer things that aren't severe.
Yes.
Do you have hard stop right now, or you have a couple minutes?
I have a hard stop. I'm actually late for my next meeting.
Okay. I'll sync up with you offline because I think there's some more comment from Seb that you should fix. I think.
Yeah,
Good
I'm
comment.
fine with fixing them, and we'll go through them. Let's just try to be a little bit faster about it, and try to if you hear the message we're rehashing things, then let's just try to say, okay, we'll stop here. We can sync offline and try to make a little more progress next week. Okay, thanks everyone. We'll talk to you next.
Thanks, guys.
Have a good weekend.
You too. Yeah.